All right. Everybody should have a measurement sheet by now. Is that the case? Is there anybody who doesn't have a measurement sheet? If there are any extras, please send it to those individuals. Okay, so let's talk about our first sheet here. Everybody in here probably knows what a cylinder looks like, right? But you may have not known that there are generalized cylinders. You're familiar with the circular cylinder, where it looks like this, and you go down here. So you're familiar with a circular cylinder, where both the bases are circles. But it doesn't have to be like that. A cylinder really is any shape that encloses a curve in a plane. Okay? So notice that this would also make a cylinder. It's also a cylinder. So I can't make straight lines or else we'd make a prism, but this is also a cylinder. As long as the bases are the same and I try to draw them the same. These are all cylinders. As you can see here in your picture, yours has like on your handout, it's more like a teardrop shape, right? It's basically trying to show to you that this is also a cylinder, okay? And you can have circular cylinders that are slanted. Like that, okay? So consider two identical closed curves contained in parallel planes. By joining corresponding points on the two curves with line segments, the result is called a cylinder. Each curve in its interior is called the base. Base over here, base over here. The remaining points constitute the lateral surface of the cylinder. So all of this stuff right here is our lateral surface, our LS. If the line segments are perpendicular to the base, the result is a right cylinder. So we would call this one a right cylinder. This would be a right circular cylinder. And that's what we all typically associate with the concept of a cylinder. But we can also have an oblique cylinder like so. Okay? Obliqueness means that this angle is no longer 90 degrees. Okay? Now, this class is starting to get very interesting because we're going to start to compute some non-trivial results of antiquity. Ancient human beings were always fascinated by what is the surface area and volume of these shapes across multitudes of different cultures around the world by multitudes of different civilizations. Okay, so let's actually discuss like number 57 here. So I'll draw it out kind of like the way it's drawn out here with similar terminology and whatnot. Okay, here's our base as we've discussed. This distance right here is the height. This distance and the distance is the same. And this is also the base, by the way. And as we've discussed, this is the lateral surface. Okay. So what if we want to determine the surface area? Okay. Who here could explain to me what the surface area of a cylinder is and how you came up with that. So you're saying surface area is equal to what? I'll put A base times the lateral surface area. Surface area lateral. Not quite. Not this part, but that's a very good guess, okay? Let me show you how you derive it. First, we will discover it together, and then you can use it as much as you want. Okay. Consider how we can construct a cylinder. Is you can take a rectangle, right? Is the pasting noise. I'm one of those weird people who thinks numbers taste and look like shapes and numbers, and I make sound effects in my head when I rotate geometrical objects. So when I glue the surface of a rectangle, it's got to make some type of noise, right? Notice we've constructed a cylinder, right? With no base. No base, it's hollow. But if we were to add some discs on top, you would get this cylindrical shell that we're talking about. So this is enough to actually calculate the what part of the problem. Yes, very good. The lateral surface area is this area. So what's the area of a rectangle? Yeah, so here's our rectangle. Oh man, no. So here's our area of a rectangle. Here's our rectangle. We convert that to the lateral surface area, right? So if this is the width and this is the length, you're telling me that the lateral surface area should be equal to what? Excellent. That's right. It's very intuitive, isn't it? Mathematics is supposed to be intuitive, right? Next.
I have a question.
Yes, ma'am.
So for the lateral surface, you're just taking it, since it's a circle, you're just making it a triangle or a rectangle. Sorry. Sorry. Is that kind of what you're showing us?
So
The length and the width?
this part right here is all of this.
Okay.
We just got the piece of paper and glued it or taped it. Yeah. And then what remains to calculate the total surface area, guys, is the caps, the top and the bottom, the base, right? Okay, so these form what shapes? Do we know how to find the area of a circle? What is the equation for the area of a circle? Let's say it's a radius r. What is the area of the circle? Pi r squared. I would love to show you where this is derived from. That would take a lot of class time. Maybe we will on an extra YouTube video that you guys can watch for fun. Okay? But notice there's two of them, right? This is just one circle. There's two circles. There's two discs that we must add the surface area to. So the total surface area, and you know what? Because I have some synesthesia, let's color code this way out. Total is equal to two of these circles, right? Plus one of these lateral surface areas. Okay? Now note, the way the handout has defined it, it defines it as a height. Okay? So one of these guys has to be replaced with a H. Okay? Doesn't matter. We can just call it W because W seems like it's the longer one. So it really doesn't matter what algebraic label we associate with that geometrical quantity. Our mathematics still holds true, does it not? Okay? This is how you find the total surface area of a cylinder. It's just it's intuitive. You could just have someone give you the formula and be like, oh, I'm just going to do what I've been told. I'm not going to ask any questions, and I'm going to be really obedient. No! That is not the kind of teachers you will be either. You will encourage a little bit of disobedience out of your students because you need to encourage following your curiosity. And they got to do something, though. You gotta get an end result. You can't just be disobedient and break chairs and slap people in the face for being annoying. Okay? You gotta actually go do something with that enthusiasm. So that's how you discover that. Moving on to the other page. Oh, take a look. We discovered this. Okay? And notice over here in our derivation, we have pi r squared. In their derivation, one of the r's is an h. Really, you convert one of your radii into an h. And so that's where the derivation leads to that statement. Potato, potato, tomato, tomato, it don't matter. Okay? Next.
Wait, I have a question that's confused.
Okay.
Why did you do the?
So that's because the circle, if it was all on its own, if we calculate the area of a disk, it's pi r squared. But you want to calculate the area of a disk associated to this amount of height. So this length right here will be the radius r. If this gets converted into h, this would be the radius r. You don't have to know how to do this for the test. This is to show you where it comes from, okay? For the test, you just have to use the formula.
Okay.
I just want to give you guys the mathematics.
But you have to multiply pi r a
Yes.
in order to.
Yes, because technically, if we wrap this around to create the cylinder, notice that this distance here is this distance right here. And so that will be the radius. Okay. So then now we're about to talk about cones. Today's lecture is a little longer than usual. Now we're going to be talking about cones. So a cone is when you have a circle and you get some point out at infinity. What does a point out at infinity mean? It just means it's a point from very far away. It could be considered infinite distance away. And this point connects to all of the points on the circle. Okay, so you create a cone, but that doesn't look like the cone you're used to, right? You're used to a right cone. That cone doesn't look right over there. So we're gonna make it right. Okay. And here's some terminology here. This is called your height, H. This is called your lateral length, L, or slant height. And clearly here's our radius. Notice that in this case, we form a right triangle. So the quantity L is equivalent to h squared plus r squared, square rooted. Then, how do we compute the surface area of a cone? Any ideas, anybody?
Would it, you could do what you did with the other one, but half it is a triangle.
Triangles are involved. Okay. So notice, if I get this circle, how much length is in this circle? What's the perimeter of a circle? Excellent. 2 pi r. So imagine I got the circle and I straighten it out. So, and I make it into a straight line. So this distance becomes 2 pi r. Okay? Now, notice what happens when I, with my imagination, create a parallelogram with that shape. This is why mathematics is so awesome and beautiful. Really, like, you can let your creativity run wild in solving problems. Okay? So let's use our imagination here. Let's imagine I get that circle and I straighten it out into a line. So that line segment will be 2 pi r in length, right? Secondly, we know this is our L, correct? What happens when we cut this shape in half is what you're referencing that with that 1/2 stuff. And you know what? I need to make it slanted. I need to make it slanted. This is called a geometrical argument. Although it doesn't look to scale, we could say if the total area of this shape would be 1/2 this piece. So this is half of the parallelogram's area, is what I'm trying to say. Is that believable? Cut it in half. Literally cut it in half. Okay? Notice that I can get this sheet now and wrap it around the cone. Yes, that's beautiful. Someone had a light bulb moment, which means if someone were to take a functional MRI utilizing positron emission tomography, you will have increased activity in your left temporal region. So that's where they come up with the formula. Surface area of a cone is equal to this 1/2, what they call CL, okay? C is just our 2 pi r. And L is just this length. We don't have to change that. Does that make sense? Again, you don't have to like come up with how to derive that surface area equation. You just have to, this is just for your appreciation. So you can appreciate how beautiful this stuff is and how it could have been discovered by a human mind. Last but not least, one of my favorite geometrical shapes. And anybody who plays sports loves this shape. It's a ball. A sphere. It's a good thing I have this face shield. It's a sphere. That would have been like a sprinkler everywhere. It's a sphere. Okay? That's how all my math buddies talk. Don't make fun of them. If y'all try and bully my math buddies, Yeah, some stuff will go down. And I know you said shin, right? Shin, shin. Okay, so spheres are like three-dimensional circles. Imagine you get a circle and put some paint all over it. Rotate it about any axis. It will paint a sphere, a spherical shell. So notice that this distance from any point from the center to the surface of the sphere can be some quantity r. So it says that a sphere is defined as a set of all points in three-dimensional space that are the same distance from a given point, called its center. The common distance is the radius of the sphere. The surface area of a sphere with radius r is given by S is equal to 4 pi r squared. I would love to show you how that is derived, but that would take quite some time, and I might do it in a YouTube video. No, I won't mind. I will. That's just the timing. Whenever I get the time, I'll do it. And I'll let you guys know when I've done it. Okay, so with this one, the surface area of a sphere is basically how much area would I get if I were to get this shape and flatten it out. So at this point, you guys can begin doing the assignment. All right, everybody, just so you know, the derivation portion, if you are still confused about how to derive the surface area of a cylinder, I've color-coded the regions and where they map to. And if you're wondering why this is 2 pi r, it's because it's the circle unraveled.
Well, yeah, so I was thinking. So this one, they just have it, they give you what it is. With a pi. So like, how do you multiply this out?
Formula right here. And isn't it probably valid for pi squared? So basically like, yeah, we've got the pi's and then just add that.
Oh, okay. So we don't solve it like this one or this one? No, we're trying to find what age. So once you find what this, you just go back to the. So you have the full square. Yeah.
Okay, I was like,
Yes. It's no square because pi r squared is the area of a circle. And what you got is two circles. So that's where that 2 in front of the pi r squared comes from. Yes. Or else you're not getting the area of a circle. And I've color coded the map, so that should make more sense with the pink and blue being the height. Blue pink being 2 pi r.
Yeah. But I got 3 What did you say?
Yes, ma'am.
That's what I said.
so I got 40.
So then 45 is more area times the height.
Uh-huh. Which height are we talking
So
about?
then 45 squared divided by.
Are you talking about from here to here? Or are you talking about from here to here? So that's 8. Yeah. But that's the same, right?
Okay.
Would you believe that? Does that make sense?
I think that's
Because the top is flat, the top is not slanted, right? Even though it kind of looks slanted in this view, really the trapezoid is flat on top and flat on bottom. So that line that emanates from this place to that place, once you found it, I can calculate the line from the center of this to the center of that place. It would have the equivalent value of the line at the edge versus the line at the center. What does it say? I'm trying not to drip on your electronic devices. The measurement of the size of the square face of the box. Measurement of the size of the square face of the box. Twice the measure of the height of the box. Okay, so if we say it's square, right? So if it has just length.
In order to write was like
So if it just has length, it's a square, right? This is all L. Then this height.
Yeah, but this is the right. Right.
This thing would be just 2L. What are you setting equal to 1 away? So L times 2L. L times 2L, which is 2L squared, just gives you one of the surface areas of the face of the box. It just gives you one of them, right? Are you trying to calculate the total surface area? Oh, the volume. Okay. What you calculated by multiplying L by 2L is the surface area of one of the faces. Just like how L squared would be the surface area here. But you want the volume, correct? So what is the volume of this shape? what equation gives the volume of the shape? Okay. Length times width times height. What is the length?
Wouldn't it be?
What is the width?
Okay.
What is the height? Yeah. So it's 2L times L times L. What is that?
I see where you got the 40. That's what I was just trying to figure
Correct.
out.
You set that equal to your 108, and you're going to algebraically solve for the variable L.
But wait.
Are you familiar with how to do that? Yeah.
Okay, so the way we were looking at it was.
Yes, ma'am.
Okay, so on this paper, it gives us the
Right, but.
Equation for what?
the surface area of the cylinder. But right now, we got a different one.
So that's because I didn't explain it well during lecture. You need to go back to this shape I have right here. The way I explained it was confusing, okay? Here's a more proper explanation. So for the lateral surface area, we take a sheet of paper that has length, the h, and width, the 2 pi r, okay? So the area, when I glue it together, is the product of these two, h times 2 pi r. So that's the lateral surface area. So total area is equal to the lateral surface area plus the 2 caps. So 2 times your pi r squared.
So it's the one on the paper.
The way I explained it was not very thorough.
I mean, I understand it.
What I was going for is trying to explain how you get the formula. You can derive the formula in a lot of different ways, and sometimes the variables are different. The way I made it is I made a cylinder that had the same height as the radius of the circle. And that's not always necessarily true.
So
Are you putting my body with 145?
Probably you should use the pi button. That's because no one knows what pi really equals. It is a transcendental number. I can leave it like that. Both of those answers are equivalent.
What's this one?
Both of those answers are equivalent, and if you'd like, you can put both of them. And that is like A plus one.
So our decimal is acceptable.
That's acceptable. Yes.
Because if I knew the decimal.
Put both of them. That way you're having your cake and you're eating it too.
How did you do that? With the tie and everything and it gave you
I thought we were, because you guys got that big number and I was like, what the fuck, mine's gonna have a 5, and I was converted. What? But this one's.
As noted on your syllabus, I'm supposed to give you 1 week of advance on when our exam will be in this class. So here it is. We will have our test in a week.
Today's date is 15th.
Maybe. Possibly. Yeah.
When will we get it?
As soon as I possibly physically and mentally can do it.
Thank you.
So what I will definitely do is create solutions to your measurements and your homework. And some people want a study guide. So tomorrow we'll have, not tomorrow, Thursday we'll have another measurement, okay? And on Tuesday, we will have a review day. The whole day will be me answering your questions and reviewing any concepts you guys want to talk about.
So the test is
Thursday.
Thursday, okay.
So that's wrong. What would I do without you guys? Always catching my slips. Yes, ma'am.
Okay, so this is that the radius is 135. So in order to actually be able to like plug it into the equation and do that all backwards and stuff, would you then end up having to multiply 145 by to get the actual surface area and then do all of that?
Just plug in the value 140 pi or r.
Why R? 4 is R.
If that's what you told me that was the plan.
I'm not gonna be clear.
Okay. That is what your surface area is equivalent to. What is this problem trying to do? The surface area of a right cylinder is measured to be this.
You need
The
to.
radius is 4. You find the height. So you have these two pieces of information. Find the height. You have to extract that information from this formula.
Yeah, so,
Because you know what this equals. And you know what 2 pi and r, 2 pi and r equal. The only thing that's unknown is h.
so, yeah, so then you would have to multiply this by 5.
You can, yes, if you want. You can get a decimal. Or you can keep it like that. It really doesn't matter. Yes, ma'am.
Okay, so we're trying to find the height. So, I divide those sides by anybody.
So if I know how to hide it, I just like everything.
That's what I'm getting.
Square root, yeah.
Huh. That is very good. That is very good. Let me check it work.
Sorry, I was
I can't read it. It's kind of small.
because that needs to be separated from the 140. Or is it just 145?
That's a great question. 140 pi is already in inches squared. So it has already been squared.
We're going
In the past, to get that 145, it got squared to get that value. So then you put in 4 for r, and then you put it into your formula. So that's 2 pi times 4 times h plus 2 pi 4 squared. Okay. The only thing I can think of that went wrong is maybe you inputted it into the calculator.
I did it 2 ways.
Okay, and it's both the same.
It's pretty much like this one.
Then it's a calculator issue. So show me how you're plugging in into your calculator. What I would do first is compute the numerator, then compute the denominator.
And section is like my, okay.
That's what I'm doing. Okay.
Well, that should be correct. Not sure why. No, because you're not evaluating trigonometric functions, so it doesn't matter. So you're worried about it equaling 3.5. If I was grading this, and I would be grading the solution to that, you could work 100% because you outgrade the solve for 8. You got 3.5. After you get 3.5, what are you saying?
I plugged it back.
Plug it in.
And it doesn't equal. Well, it needs to be equal to 140
I
pi.
get to accept it was this one.
140 pi is 88. It needs to be 140 pi. 140 times
So when you
pi.
get 188, what do you do? How do you get pi?
So
Does it make sense?
type in 140 times pi. And is that what you're saying? Equal to 188?
No, like when we plug it in, we get 188.
We plug in for the 140, we plug the H card in here, it's
Correct. Right. What is the numerical value of the number 140 times the number pi?
Yeah, so we might.
That should be equivalent to what you get on the right hand side. I didn't make this up, so I don't know why it's happening. Probably the person who created it didn't double check this fact. I can understand why you'd be frustrated about that.
And
I just raise your hand and ask me. I would give that 100%.
So we could put a.
3.5 is correct. But it should, as you guys are wondering, it should be equal to that.
It should be.
It should be
It
equal
should
to
be.
145. It should be equivalent to that. That is very annoying, and I'm annoyed with you.
I just know it was awful.
So you just put it over.
Yes, ma'am.
And today. Which
So 13.5 is equal to pi h, right? So you need to also divide by pi. Prior to doing that, you have to like yes, very good.
It shouldn't be 144. It should be safe.
Okay, can you send me a picture, please?
Well, and it looks better.
Yeah. Yeah, if you send me the picture, I can recognize which one it is. That way it's there permanently, and if I made an error, I can go back and double check. But if I recorded just now, you know, I may be like really sleepy and I may mess up. I believe I've uploaded the values onto the canvas.
Well, I didn't see it last time.
Oh, if it, okay.
I don't know if you have sent it.
If you do all of them, that would be great. That way you cover all the bases. I appreciate you guys. Thank you. Yes, yes, sir.
Square
Exactly. That's a good question. Each is squared. Means it's already been squared in the past. You don't have to do any more squaring. That's just a unit. You had a pi in front of it. Well, I'm assuming you guys factored out the pi and divided both sides by it, right? What did you do? Put the pi in. I was gonna say, you have to factor out a pi, so this term that turned yes. But you need to know why that works.
And then
Let me see your paper. I just need to see it right.
4 squared is equal to 145, right?
So would you?
Both of them, because if you factor it at each term, notice this had pi, this had pi, both of them will multiply because factor it out. That's one way to do it. Another way to do it is just multiply the pi through to the numbers, and then just do decimals. They're all equivalent. That is the more elegant and mathematical route. Is to take the pi out.
Oh, it's just like the other one.
Yes.
So like,
So yes.
where's the formula?
Yeah, and then you divide by pi. Why would I do that? Well, I guess it makes sense.
You can type the whole thing and you just round.
Oh, and so then you divide it by 80, or that's how many.
Yeah,
Okay.
it is.
Because it's not squared because it's already squared.
Okay.
Well, you're solving for a height. A height is a length, and length is an inch. An area is an inch squared, and a volume is an inch cubed.
You have to get everything that's the same on the same side. So this is 8 by 8, and these, this is 32.145. So you would subtract 32 from 140. So you have all your pi on one side and all your pi 8.
So basically, so just to really quick, you basically just took this.
Yeah, that's what
108 pi. And this is where you have 8 pi 8. So then what you do is you have your 108 pi and your 8 pi 8. So maybe pi. So in order to get that 8 by 8, you need to divide 8 by. Yeah, then pi and 8 are multiplying, and then adding and subtracting. 13.5, and since we left the area in by, exactly divide that by 8, it's fine. So really, I feel like it would be complicated.
So what, let's we have to figure out what our, hold on, what's 48 divided by 2? Because if you did, what is 24 squared? Yeah, it's right, it should be 24. Not 24 squared, I'm just gonna
Is C always going to equal pi r?
Yes, because C is the circumference.
Okay, okay, it's gonna be whatever.
Oh, I see.
I don't think they're.
Wait, you're fine with this.
Right, so for a cone, what's that? The area of the cone.
I just feel like there's an easier way, but I'm mad.
Yeah, but see if shift circumference is actually.
Close enough, making 47.99999. So the second root of, right? So I'm saying that R is 3 times.
Is L that high?
L is the length. So you have to
Yeah.
do the square root of H squared plus R to the
And then you will apply yourself on the side and they get all that.
So R equals 3.9. Okay, so you know that slant height has another equal twice of that. So height is going to be 3.9 plus 2. But then you have to have height, right? So which is twice that. Yeah, it's like I land on story. Well, I said slant height. Yeah, but it's the slant height has another equal twice that as the radius of the base. So it's just the height equals 7.8. What all do we serve? We need the slant height.
How, whatever this is.
So we have the radius. About this length.
C and L.
So E equals 2 pi R. So literally, yeah, you don't need this. This really can't. Because we're on the cone.
And I'm gonna do my like normal height. So this one's asking for a rectangular cone.
Yeah.
S equals A plus 1. Then,
I don't know, I use.
oh, we need to find, yeah, so the surface area.
I have another question.
Yes, ma'am.
So
So are we finding some like dimensions? Is that the A, the L, or the C? That's what it is, right?
No, I think 18, the height.
Correct. Because are you doing stuff with spheres?
Slant height is
You're still
L.
doing the cone?
That's how you find the slant.
Well,
But you have to actually find the height
if
first.
you're using a cone, you want to use formulas that apply
So
to
this
the
is,
cone.
so this is the slant height formula.
yes.
Which other one?
This one.
I can do it, but now we just need to put slant height equals height.
That is the surface area.
Oh, so that just gave us the radius?
That gave us the slant height.
Takes that.
L is, we have to figure
So
out.
C is equal to 2 pi R.
So that's gonna be.
A is the area of that circular base. So you have to include that, right? That derivation of like 1/2 2 pi R L just gives you the lateral surface area on the cone.
Oh, about one of
Yeah,
these.
this is for the lateral surface area of the cone. Add that base area of the surface.
Okay, so the radius are, yeah.
2 pi R squared. Very good. Yeah.
It would be area
Area of that disc in the base.
Oh, so give it, oh. So
But it's just a circle, right? What's the area of the circle?
I know this.
So you can calculate that.
It's like using the A first. Well, I see, you've got to be real.
That's probably, that's what,
Oh, yeah. Okay. Because I didn't tie back to it. No, yes. Because this right here just found this. So we have to now find the circle and we just do the area is going to find.
Why is that included in the equation?
It's just on this.
Yeah.
Yeah, all you have to do
Yeah,
is
it's
put
solid.
5 squared, like, into the R, so then it comes out to be 7.
1/2 2 pi r.
You can't just divide by the square root.
Yeah, I was just
Because,
going
it destroys the
S
laws of
equals
algebra.
A plus half C. The area of pi r squared.
No,
That's the
the
circle.
square root does not distribute across addition and subtraction, but it does distribute across multiplication and division. This is very good, very good.
Yes.
So here's what you do. Is there something I can write? So,
So just to just to make sure, we're finding what these are, right? We're finding what C and L and A are for this answer. Okay. I just wanna- Yeah, what are the dimensions? What does it mean?
what do you mean, dimensions of surface area?
The question is, what are the dimensions of the cone if the area is 48
Yes, they're asking for the height, the radius, and the lateral slant.
So all of it,
Yes, ma'am.
not this.
Yes, ma'am. Okay, so in terms of the algebra, show me where we were at last time. Okay. So
So it started.
what does that say, 7.8 to, okay, you can't just divide, you have to get rid of that radical first. So the way to do that is to square both sides of the equation.
This right here
Okay.
finds the
This,
area
yes,
of the
okay.
bottom.
So this is set up here. We want to figure out how to solve for a square if it's inside of a radical like this. You have to get this hand side and that hand side set them equal to each other, and this radical has to go away if we're ever to solve this h squared. So you square both sides,
Oh.
but this becomes x squared. Then the radical disappears because the squaring of the radical just makes the radical go away. Now you can solve for h. It's not divided, it's subtracted. And then you take the square root. Does that make sense? Mhm. Yes.
Oh, no, I just put that, I really That's, yeah, her, I was like, Sean.
Yes, ma'am.
How did it get started on this one? It said you gotta find the dimensions, you gotta find the radius and the height,
And that slant line.
and that's one. And all we got is the surface area.
So what is the equation of surface area?
1/2 2 pi r times L plus 2 pi r squared.
So notice that all of the dimensions are in that formula. The r's in the formula. The r's in that formula. Well, you're also forgetting
That's part of
to add the area of the circular base, right? Plus that 2 pi, plus that pi r squared at the base, right? So,
Okay, so
this is a plus. So now, what you need to do is algebraically solve for r.
1.5 squared.
You can solve for r here.
Oh.
If she divides, if that divided by pi, you just have to you need this entire number, you got pi with it. That is, yeah. So we need to know that how many gallons with this number. What else do we have?
So we have equations for this.
Yes, ma'am.
Yeah. Okay, so, and we're just putting the, can we multiply to do 5 pi?
Yeah.
And multiply this by 5?
Yeah.
And then divide?
You didn't divide yet. Because
So,
you can't divide that because you have plus that pi r squared. You can only divide your determined all.
yes.
Okay, so
First, what you have here, you got a cone, the slant height is twice that of the radius of that. So that L can get converted to what? That L needs to turn into what? You read the question.
And you would.
Well, read the whole question out loud. Just read it out loud for me.
For right,
There you go. There we go. Does she know something about L?
The height is, I'm going to do something about the height and then
Read the first sentence of the question out loud slowly.
It's not that we did the math, we just, the very beginning, we got right. Everything else we took.
But it says in the thing.
Yeah. So what does L equal? First off? Yes. Yeah. 2R.
Well, the square root.
So you can replace it in the equation. Yes, ma'am. You can algebraically solve for R now.
When we did, okay, because you multiply these two together to get 4 pi r squared.
Yes, ma'am. From the problem, later, it says that you've got percent. So it says that the point height is twice the length of the radius. So L is equivalent to 2R. You can algebraically solve for R now. Yeah.
You were on the right.
Yes, ma'am.
Okay, so that gives you 4 pi r squared and pi r squared. So you add them together to get 5 pi r squared, right?
4 pi r squared plus pi r squared is definitely 5 pi r squared.
Alright, so then could you divide that 5 by 24 to get 5 pi r squared? Alright, and then so I don't know what the next step, because we divide by 5.
And what is that? Divide by pi just cancels the pi's out, right?
Sorry, I was still.
It's pi over pi. Divide both sides by pi. Divide by itself before.
Okay, we're done. But in the end, the radius equals 2.1.
So you want to algebraically solve for R. So there's two ways of approaching it. Two ways of approaching it is to get a common denominator. So this is adding something to the fraction. Another way to do it is a similar method to dividing out by 5. Instead of factoring out by pi, is you can factor out by R squared.
Oh, great.
Divide out by R squared. You guys want pencil? You guys want pencil? So you get R squared times becomes a 1 plus 2 over, what is that? Another way to think about it is that the 2's cancel, so you're really just getting R squared plus R squared, which is 2R squared. Then you can algebraically solve for R.
We have to find the height.
What does it ask you for?
The dimension.
Uh-huh. So then, is that part of the dimensions? Is it? That's fun to do.
I just put all the things here.
You have your hand up?
So then technically, you have my
Hot sauce, I think. No, don't worry. I won't tell them. Any of the cash. I'm actually happy you're enjoying yourselves while doing that. Are you trying to push for more time? Who here wants some more time on this assignment? Because it's 1 o'clock right now. Okay. You can have, you can turn it in on Thursday. Good work. Good work.
Thank you.
Good work. Good work.
Thank you.
You have more time if you need.
Yeah, but I
If you're done, you're done.
it in, yeah.
Okay. Good work.
Thank you.
Good job.
Like, we need homework.
Good work.
Honestly, I'm just gonna print it off. Because
There
I'm
you go.
gonna lose that.
Good work.
Thanks for the extension.
No problem.
Like, am I doing a hypocrite right now? Okay, so I wasn't like that. I don't like being a hypocrite.
Good work.
Thank you.
Eso.
Tengo casi todos.
Ok.
Me faltan 3.
Ok.
Esto, ¿vale?
Si puedes hacerlo en un
Sí,
día más.
Lo voy a hacer hoy.
Ok.
Pero entrego el jueves.
Ok.
Well, I don't know that one number. Yeah.
With me, I got permission, it's coming home.
Good work.
Lo hicimos.
Very good. Good work. Good work.
Ya lo.
Okay.
Bye.
See you. Got a question?
Just one real quick question.
Yes, ma'am.
Okay. So figuring it out and I'm left, okay, so I had 2 squared on one side times 2r. That's what I was left with. And then I got a 24. The square root of an r, right? You can square root one side. You can square root 24 and you bring down.
1 second. So over here, this is the total area of a cone. You have the area of a circle,
Yeah.
pi r squared, that's good. And then you have this 1/2 2 pi r squared. That should just say 2 pi r.
Okay.
This needs to just say 2 pi r, not
Oh,
squared.
not squared.
Mhm.
Okay. Wait. Oh, see. Oh my gosh. So it would.
Little mistake, yeah.
So technically, if I x-nayed that, I'd still be left with my original answer, which
Let's
is
see. All right.
possibly.
So this should be 4 pi r squared once you're done. And then this becomes,
Let me get rid of the squared.
right,
Okay.
that needs to go away. So,
Okay.
so then
I can.
this over here. So this is just going to be r times 2r,
and then I could
which
just.
is 2r squared. Yeah.
Exactly. And technically, if he lets.
Raina, we might have been right because I added a square to ours, so you might.
Yeah, I think you're good.
So you had, what is it called? You had you had something like 24
24
Is
equals
equal
to 2 r
r
squared.
times 2r, right?
Yeah, r times 2r, which would be 2r squared. Right?
Very good.
Okay. And then you square root 24 still.
And so what's square root of 24?
4.9.
Sure.
I mean, that's, I think, quite good.
4.9, and that's equal to, this
Um,
becomes r,
R.
root 2.
Well, what about 2? You're left with, oh, okay, r
The
root
square root
2.
distributes, so
Okay.
it becomes square root of 2, square root of r squared, but that's the same
Right.
thing as r root 2.
Okay.
And
So
then you
you're
can
left-
divide by root 2.
Root 2. So you're left with 4.9 equals r and square root of 2 divided by the square root